Well, welcome back to lesson 4 in our unit on quadratics. Today you notice I'm sitting down. You gotta remember I'm getting old. I turned 50 this summer. So I'm gonna do this lesson seated. Before we move on in the quadratics, we've got to look at something that we looked at earlier in the year a little bit, and that's the technique of factoring. Factoring is the opposite operation of multiplying. 2 times 5 is 10. We say 2 and 5 are factors of 10. 10 factors into 2 and times 5. So if I look at this expression here, this reads 3 times this trinomial. These are factors that are to be multiplied. And the way I do this is distribute 3x squared plus 18x plus 3. So that is multiplying a monomial term times a trinomial. Factoring would take this 3x squared plus 18x plus 3 and rewriting it into 2 factors like so. We say that 3 is the greatest common factor of 3x squared plus 18x plus 3. So this process of working backwards here is called factoring out the greatest common factor. Looking at this trinomial, what I want to look at is first the numbers. What is the greatest common factor between 20, 10, and 15? What is the biggest number that divides those evenly? Well, it's 5. So over here, I'm going to write it out, GCF, my greatest common factor, 5. But I'm not done. Do they have x's in common? This contains 3 x's, x times x times x, 2 x's, 1. How many do they have in common? Well, they all have at least 1. So I can factor out an x. So my greatest common factor is 5x. So that is what is going to be pulled to the outside. And I've got to write what is left. And if I start with the trinomial, I'm going to end with the trinomial. And a couple ways to look at this. You can say, okay, if I factor 5x out of 20x cubed, what is left? Pull a 5 out of 20, what's left? Well, what I'm saying is 5 times what is 20? 4. If I pull an x out of x cubed, what is left? Well, if I pull 1x out, that's going to leave 2 x's there, or x squared. Or I can think x times what is x cubed? X squared. Likewise, going to my next term, keep the minus sign there. Pull a 5 out of 10. 5 times what is 10? 2. Pull 1x out. That leaves 1. And then the last term, pull a 5x out of 15x. That's going to leave a 3. And there are no x's left. All right? Now that's something we've done before, and this is kind of a review here. But one thing I want you to keep in mind, whenever you're asked to factor an expression, always look to factor out the greatest common factor first. Always. So looking at this expression here, take a minute and pause the video and see if you can factor that. Hey, you're back. Good to see you again. Now, looking at this, my greatest common factor here, well, I look at the numbers. That's got a 3. The number right here, that's a 1. You just don't see him because he's so skinny. Greatest common factor between 3 and 1 is 1, and factoring out 1 doesn't do anything. Look at the x's. That's an x squared, that's an x to the first. I can factor an x out of each of those. between these, let's see, that's a y, that's a y, I can pull a y out. So my GCF, my greatest common factor, is xy. So that is what I'm going to pull to the outside. Now, I factored out of a binomial, so there will be a binomial left. I'll have something minus something. Pull an xy out of here. Of course, my 3 is still there. I pull one x out, that leaves 1. And I pulled a y out, so there are no y's left. Now here, I pull an xy out, and it appears that there's nothing left, 0. But that can't be, because if I multiply back through, I got to get what I started with. Xy times what is xy? 1. There's always at least a 1 left. And reminder, always look for the greatest common factor first when factoring. All right. Now, let's be more specific about what type of factoring we're going to be doing, and that's factoring quadratics. Now, at the beginning of the term, we talked about factoring trinomials. And let's just, again, go back and refresh our memories here. Multiplying two binomials, because again, factoring is the reverse process of multiplying. So we're going to work backwards first. Multiplying these two binomials, I've got to use distributive property, x squared minus 5x. But I've got to take every term in the first binomial times every term in the second. So I've got to distribute that positive 3 also. Now, the middle two terms here I can combine. They're like terms. Minus 5x plus 3x is minus 2x. Now, again, factoring is going to be working backwards. Starting with this trinomial, breaking it into these two factors. Now, what I note here is, well, okay, trinomial factors into two binomials. The first terms have to be x to get my x squared when I multiply them. My last terms have to multiply to give the last. But I notice that they also add up to the second. So when I'm factoring a trinomial into two binomials, my first terms are x, and for my second terms, I look at factors of my last, c, that add up to my middle, b. For example, this one here. Trinomial, if it factors, not all do, it will factor into two binomials. First terms are x, and now to get the second terms, I'm going to look for factors of negative 8 that add to positive 2. Can you think of any? Now, if you're not sure, go off to the side, write out all the factors of negative 8, see if that helps you, okay? I bet you can do it. Let's see. Factors of negative 8, one will have to be positive, one will have to be negative. Positive 4 and negative 2. Now, you can test this. Did I factor correctly? Distribute x times x, x squared, x times negative 2, negative 2x, 4 times x, 4 times negative 2. And I do indeed end up with the correct, or what I started out with. This one here, you try it. Pause the tape. You're back, good. Now, this one, again, I'll factor into two binomials. First terms will, again, have to be x. Looking at factors of 12 that add to negative 7, well, in order to add, or multiply to give 12 and add to negative 7, they'll both have to be negative, because negative times a negative is a positive, negative plus a negative is a negative. So let's see, I'll run through the list of factors and which pair work. -3 and -4. All right, but you knew how to do this already, didn't you? I knew you did. One last special case I want to look at, and that is a special pair of binomials we're going to multiply together. X plus 3, x minus 3. Notice that these have the same terms, but the second terms have opposite signs. These are called conjugates. Conjugates. Now, when I multiply these together, I get x squared minus 3x plus 3x minus 9. Notice what the middle two terms do. They cancel. And actually, I end up with x squared minus 9. I ended up with the first term squared minus the second term squared. Well, that gives us a formula. It's called a difference of squares. If I recognize I've got something squared minus something squared, it will always factor into the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Now, another way of looking at this, some people don't like to memorize that difference of squares. How can this relate to the type of factoring we just did? Well, it's not a trinomial, but it can be written as one. X squared minus 9, I can say that's plus 0 x's minus 9. Now I've got a trinomial. So I can simply go back and look at factors into two binomials. And I'm looking for factors of -9 to add to 0. That's plus 3 and minus 3. Now, before I leave you with a couple problems to try for homework, I want to caution you. If I ask you to factor this guy here, you might be a little bit stumped because you're thinking, it's not a trinomial, but it's not a difference of squares because 3 is not a perfect square. What should you always look for when factoring? That's right, the greatest common factor. So I factor out a 3, but we're not done yet. After I factor out the greatest common factor, I'm going to look, can I factor this further? Oh, a difference of squares. Perfect square minus perfect square. That's going to factor into x plus 5, x minus 5. That is what we call the complete factorization. This is a halfway factorization, or a something factorization, I won't say. All right. Now, I believe you accelerated brainiacs probably knew all that, but a refresher is probably good. I would like for you to just try these 3 problems, bring them to class tomorrow. That could be a quiz grade. Okay? Copy these 3 problems and give me the complete factorization. See you in class.